Hello everyone, I am going to explain question number 3rd and question number 4 of exercise 7.2 of class 12. So as you can see in exercise 7.2 we are differentiating the inverse trigonometric functions. So here the question is we have to differentiate cos inverse 4x cube minus 3x with respect to x and where x belongs to 1 upon 2 to 1. So first we'll assume whatever given function as y, that will give us the equation 1. Now here we need the substitution, we have to simplify it, and if we clearly observe, we found that instead of x, if cos theta should come, then it's going to be in the form of cos 3 theta formula, then cos and cos we can remove. That will give us the hint that we have to assume x as cos theta. So we'll assume x is equal to cos theta. That will give us cos inverse x is equal to theta. Now we'll replace here, instead of x we'll replace cos theta. Now after replacement we found that this complete bracket is in the form of cos 3 theta formula. So we'll replace it and here we'll write down cos 3 theta. Now we have, before cancelling, we have to see whether the principal value is satisfying here or not. So we'll write down the form given thing that x belongs between half and 1. Now what x we had assumed? Cos theta. Now we'll take cos inverse in a complete in equation. Now cos half. Cos inverse half is at pi upon 3 and cos inverse 1 is at 0. Now because here is we have 3 theta, that's why we multiply it by 3 in complete in equation. Now here we will get pi and here 3 theta and 3 into 0 is 0. So we obtain pi to 0. This 3 theta belongs between 0 and pi. So what we have here, the principal value of cos inverse x is between 0 to pi, and here also we obtain 0 to pi. That's why we can easily cancel this cos inverse and cos, and we'll obtain here 3 theta. Now theta we will replace from equation second. We'll obtain theta as 3 cos inverse x. Now we'll differentiate it with respect to x. So when we differentiate it, it's a coefficient, so it will come in front, and cos inverse x differentiation formula is minus 1 upon root 1 minus x square. So it is just opposite of sin inverse x. So like this also you can learn. Hence this first part of question 3rd is completed. Now second part of question 3rd is we have to differentiate it. So we'll assume this as equation first, and here the boundation of x is not available, so easily we can do this. Now since here is cos, so assume this x as cos theta and shift this cos here, so you will get cos inverse x as theta. Now replace this value of x in this equation. So that will give you root 1 plus cos theta upon 2. Now 1 plus cos theta. Now its value you should learn that 1 plus cos theta is 2 cos square theta by 2. Now how this result obtained? For this, see this. The formula of cos 2 theta is cos square theta minus sin square theta. Now when 2 theta is there, that time what happened here? Theta means half of 2 theta is theta. So if instead of 2 theta, if we have only theta, then it's going to be theta by 2, and here also theta by 2. Now that is the formula cos theta. Now this sin square theta by 2 just replaced by 1 minus cos square theta by 2 from identity sin square theta plus cos square theta equal to 1. Now open this bracket, add it. Now this, when you will open it, you will find that this 1 is going to be negative. So this 1, when you will shift here, it is going to be cos theta plus 1. Now cos square theta by 2 and this cos square theta by 2 both are positive, so it's going to add. So we obtained 1 plus cos theta's value is 2 cos square theta by 2. So instead of 1 plus cos theta, replace it by 2 cos square theta by 2. Now this 2 and 2 will cancel each other, and this root and square will remove each other. So we will obtain only cos theta by 2 here. So in next step we have only cos theta by 2. Now this cos and cos is removed. So we obtain here theta by 2. And from equation second, theta's value is cos inverse x. Now differentiate it. When you will differentiate, cos inverse x differentiation is minus 1 upon root 1 minus x square. So multiply them, you will get this. So hence the third question is completed. Now question number 4. In question number 4, we have this question. So we'll assume this question as y. So that is your first equation. Now we need to do the replacement. So x will replace here by theta. Now from here theta is going to be cos inverse x. Now instead of this x, write down cos theta, do this replacement. So this equation 1 becomes like this. So 2 cos square x minus 1 is cos 2 theta from this formula again. So it's very important formula, students. So from this cos 2 theta formula, many formulas arises like 2 cos square x minus 1 is this. So here students, here theta should come, by mistake I wrote here. So make here theta. Now just observe this formula first. Cos 2 theta is cos square theta minus sin square theta. But here we have only cos, we didn't have sin, so sin just replaced by cos, that is sin square theta is 1 minus cos square theta, open the bracket, that will give you 2 cos square theta minus 1 is cos 2 theta. So this complete just replaced by cos 2 theta formula from this. Now this cos 2 theta, 1 upon cos 2 theta is the formula of sec 2 theta from the reciprocal. Now from the reciprocal we obtain here sec 2 theta. Now sec and sec we remove. Before that we have to, because in this question again the boundation of x is available, so we have to check the principal value satisfying or not. So we'll start from the given in equation that x belongs between 0 to 1 upon root 2. 2 will come here. Then x we will replace by cos theta, because we assumed x as cos 2 theta, cos theta sorry. Now take cos inverse to the complete in equation, that will give you this. Now cos inverse 0 is pi upon 2 and cos inverse 1 upon root 2 is pi upon 4. Now since we have here 2 theta, so multiply this complete in equation by 2. So we obtain pi and pi by 2. Now sec inverse x, because here we have sec, so sec inverse x principal value is 0 to pi, and in this y cannot be pi upon 2. This is the formula of principal value of sec inverse x, which you might have learned already in second chapter. Now here what we have interval pi by 2 to pi. So pi by 2 to pi belongs in this interval. That's why we can remove sec inverse and sec. So we obtain only 2 theta. Now theta value from the equation second is cos inverse x. So cos inverse x differentiation is minus 1 upon root 1 minus x square. So first part of question 4 is completed. Now second part is this. Now here the question is y is equal to cos inverse 1 minus x square upon 1 plus x square. Student, we had this question before also, but only in this constraint is changed. So here we assumed x as tan theta. After replacement we will get here cos 2 theta. So cos inverse and cos will remove each other. Before that we will see here. Now x will replace by tan theta. Take tan inverse in complete in equation, that will give you this. Tan inverse 0 is at 0 and tan inverse infinity is at pi upon 2. Because we have here 2 theta, so multiply it by 2, so we obtain this. Now because students we are doing for cos, so here just take the principal value of cos inverse principal value is 0 to pi, which is satisfying. That's why cos inverse and cos inverse replace, so we will get here 2 theta. Now 2 theta from equation second is tan inverse x. Now differentiate this tan inverse x with respect to x, that will give you tan inverse x formula is 1 upon 1 plus x square. Hence the question number 4 also completed. Thank you.